What's up guys, and welcome back to another tutorial right here in the Calculus Storage channel. Now, to go ahead and get started, let's go ahead and jump right into this exercise. So, the figure shows a clock standing on a level floor with a close-up view of the clock face. The clock face has a 10 centimeter long moving hour hand. The center of the clock face is 200 centimeters from the floor. At time t is equal to 0 hours, the hour hand is pointing directly up to the 12. The next time the hour hand points directly up to the 12 is at time t is equal to 12 hours. As the hour hand moves, the distance of the endpoint of the hour hand from the floor periodically decreases and increases. The sinusoidal function h models the distance in centimeters of the endpoints of the hour hand from the floor as a function of time t in hours. Now, for part A, the graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. Determine possible coordinates for the 5 points F, G, J, K, and P. Now, to go ahead and get started with part A of this exercise, let's go ahead and do a recap on what the variables mean. So T represents the hours on the clock. At T is equal to 0, our hour hand is pointing up directly at 12 on the clock. And at T is equal to 12, it returns back to its initial position. Now, h of t is the distance between the tip of the hour hand and the floor. Now, to go ahead and start finding those points, let's go ahead and choose several t values that are going to help us map out this periodic function h of t. And so let's go ahead and start off with time is equal to 0. And so drawing our clock right here, let's go ahead and put those distances. And so we know from the exercise that the distance between the floor and the center of the clock is 200 centimeters. But we're not interested in that distance. We're interested in the distance measured from the tip of the hour hand to the floor. And so the distance from the center of the clock to the tip of the hour hand is 10 centimeters. And thus, to go ahead and get the full distance, we'll have h of t is equal to 200 centimeters plus 10 centimeters, which is 210 centimeters. Now, at time is equal to 3, we have our hour hand in the following position, and notice that it is perfectly level with the center. And so to get the distance from the tip of the hour hand to the floor, it's just 200 centimeters. Thus, h of t is equal to 200 centimeters. Now, at time is equal to 6, our hour hand assumes the following position. Now, in this scenario, to go ahead and get the distance between the tip of the hour hand to the floor, we'll go ahead and subtract the 10 centimeters from the 200 centimeters, and that's going to give us the distance between the tip of the hour hand to the floor, which is 190 centimeters. At t is equal to 9, the hour hand assumes the following position. And so similarly, like at time t is equal to 3, the distance between the tip of the hour hand to the floor is 200 centimeters, and thus h of t is equal to 200 centimeters. And finally, at time t is equal to 12, we return to our original position And so h of t is going to be 10 centimeters plus 200 centimeters, which is 210 centimeters. Now, with these values, we can go ahead and come up with a table that shows the relationship between t and h of t, which is the distance between the tip of the hour hand to the floor. And so at time is equal to 0, we are a distance of 210 centimeters from the floor. At time is equal to 3, we are 200 centimeters. At time is equal to 6, we are 190 centimeters. At time is equal to 9, we are 200 centimeters. And at time is equal to 12, we are 210 centimeters. And so by coming up with the following coordinate system, we can just go ahead and refer back to the beginning when we were given that picture showing points F, G, J, K, and P, and fill in the corresponding coordinate points. Now, in this exercise, we want to go ahead and describe the function h of t that describes the scenario that we just saw. And so this means we have to find the values for a, b, c, and d. Now, we'll go ahead and make use of the picture that we came up with in our last exercise. And this is going to help us as we try to find all these different attributes for our h of t function. Now, if you go ahead and remember the general format of a sine function, a is the attribute that represents the sine function's amplitude. An amplitude is just a distance from the midline to a peak or a trough. And so from our picture, given that the midline has a value of 200 and the peak has a max value of 210, the amplitude will be 210 minus 200, which is the distance between the midline and the peak, which comes out to be 10. Thus, a is equal to 10. And so by substituting this value into our equation, we get h of t to be 10 sine of bt plus c plus d. Now, the next thing that we can go ahead and find without too much math involved is the vertical shift. Now, in this situation, to go ahead and get the vertical shift, we just go ahead and look at the h of t value of the midline. And so given that the midline has an h of t value of 200, the vertical shift is 200, and thus d has a value of 200. And so substituting this into our equation, we get that our function h of t is equal to 10 sine of bt plus c plus 200. Now, to go ahead and get b and c, it'll go ahead and take a bit more effort, but definitely doable. Now, remember that an important part of a sine function is its period. The period of a sine function is defined by the equation period is equal to 2 pi divided by b. Now, the first thing that we have to do in our pursuit of finding what b is to go ahead and find the period for this function h of t. And so one of the easiest ways to go ahead and get the period of a function like this is to analyze a peak and travel along the independent axis until you get to the initial value as in the beginning. And so if we go ahead and go up to our picture, we have a peak right here at the letter F. And so at time is equal to 0, we have a value of 210. And so as we travel along our independent axis, which in this case is time, we arrive at this point P, whose value is at t is equal to 12, the same as in the beginning with a value of 210. And so at t is equal to 0, our h of t value is 210 centimeters, And when we get to t is equal to 12, our value is once again 210 centimeters. Thus, the period for this function is 12. Now, by finding the period, finding b becomes a much more easier task. And so we'll write out our equation, which is period is equal to 2 pi divided by b. And substituting in that value for period, we get 12 is equal to 2 pi divided by b. And finally, solving for b, we get b is equal to 2 pi divided by 12. And through simplification, 2 pi divided by 12 is just pi over 6. And so by substituting in this value for b into our h of t function, we get h of t is equal to 10 sine of pi over 6t plus c plus 200. Now, for our final letter c. To go ahead and find c, let's make use of a point that we know is true and use that condition to find c. So a point like 0, 210 is going to work, and it's going to help us as we find the value for c. And so let's go ahead and take the equation that we formed up to this point, and wherever we see at, we'll go ahead and plug in a 0. And so the equation becomes h of 0 is equal to 10 sine of pi over 6 times t, which in our case is 0, plus c plus 200. Now, we know that at time is equal to 0, h of t is 210, so we can just go ahead and replace h of 0 with 210. And so we'll get 210 is equal to 10 sine of pi over 6 times 0, which is 0, plus c, and then plus 200. So let's go ahead and start simplifying this equation by crossing over the 200 over to the other side by means of subtraction. And so by subtracting 200 from both sides, we'll go ahead and get 10 is equal to 10 sine of c. And then let's go ahead and get rid of that 10 on the right hand side by dividing both sides by 10. And so we'll get 1 is equal to sine of c. And so now that we have our equation condensed to this point, let's go ahead and think back to the unit circle and think of a value c such that whenever you take the sign of it, we get 1. And so referring to the unit circle, we know that this happens at a value of c such that when c is equal to pi over 2. And so by finding this value of c, we can just go ahead and finish our equation, and our h of t equation becomes 10 sine of pi over 6t plus pi over 2 plus 200. Our final answer. Alright, so I'll go ahead and see you guys next time. If you have any questions, just go ahead and drop those questions down in the comments, and I'll see you later. Take care.
Artlist.io